So the collision cross section, that is the cross sectional area of an imaginary sphere surrounding the molecule into which the center of another molecule cannot penetrate. So which is the pi sigma square. Now you listen. So this is called a collision number. Please, I request everyone to pay the fullest attention as the other parts contain more mathematical expressions. What is collision number? It is the number of collisions suffered by a single molecule per unit time per unit volume of the gas. Suppose if I take 1 liter of the gas, in 1 second, what is the number of collisions experienced by one molecule? It is called the collision number. And the expression is Z1 is equal to root 2 pi sigma square. What is sigma? Sigma is a collision diameter. And C, this is the average velocity, into rho, which is the number density. What is number density? Number density means total number of molecules divided by volume of the molecule. That is number per volume is number density. Now the total number of molecules colliding So the total number of molecules colliding per time per unit volume can be written as root 2 pi sigma square C into rho square. Why rho square? You are going to calculate the total number of molecules colliding per time. So number density square. So each collision involves 2 molecules, because 2 molecules alone can collide with each other. If there is only one molecule, it can collide only on the walls of the container. It is not going to collide among themselves. So each collision involves 2 molecules. Therefore, the number of collisions of like molecules occurring per unit time per unit volume is, look here, it is Z11. This is the total number of collisions. So two molecules are colliding means just half of that. Number of collisions like molecules occurring will be just half of that. So 1 by 2 into square root of 2 pi sigma square C and rho square. This 2 can be taken as root 2 into root 2. Therefore, one root 2 and another root 2 here can be cancelled, and what you are getting is 1 by root 2 into pi sigma square average velocity and number density square. So this is called a collision number. So this is what is collision frequency? Collision frequency, the number of molecular collisions occurring per unit time per unit volume. Number of molecular collisions occurring per unit time per unit volume of gas is called the collision frequency. See, look here. Z11 is equal to 1 by square root of 2 pi sigma square average velocity and number density square. If there are 2 types of molecules, what will happen? Type 1, type 2. What is the collision frequency there? It is 1 by root 2 pi sigma square average velocity and the number density of type 1 molecules and the number density of type 2 molecules. So look here, you know PV is equal to nRT according to ideal gas equation, and ideal gas equation PV is equal to nRT. This N is a number of moles. This number of moles is nothing but, if you want to calculate a total number of molecules from number of moles, it is number of moles into Avogadro number. This Avogadro number actually I am taking from this universal gas constant R. R can be written as Avogadro number into K, the Boltzmann's constant, into temperature. So number of moles into Avogadro number will give you total number of molecules, capital N. So the equation can be written as N K T. So pressure is equal to number of molecules divided by volume into Kt, where this N by V is nothing but number density rho. Therefore, number density rho is equal to P by Kt. That P by Kt is substituted in the place of rho. Therefore, Z1 is equal to square root of 2 pi sigma square average velocity into pressure by Kt. And the collision experienced by two molecules, it is Z11 is equal to pi sigma square C pressure square, because this is rho square, no, pressure square by K square T square, which is written as Kt the whole square, root 2 is come here. So the unit for Z1 is per second and the unit for Z11 is per second square per meter cube, per second square per meter cube. So these units are very important. So the next idea is mean free path. The mean distance traveled by a gas molecule between two successive collisions. See, one molecule is coming, it hits on another molecule and then it moves away and again hits on another molecule. So between two hits, two successive collisions, what is the distance traveled by the gas molecules? So that is called a lambda. That lambda is actually the average velocity divided by Z1, the collision frequency. So this average velocity is a C average divided by root 2 pi sigma square, again average velocity P by Kt. So this average velocity can be cancelled. Therefore lambda is equal to this Kt will go to the numerator, Kt divided by square root of 2 pi sigma square into pressure. So from this what you understand, when pressure increases, mean free path decreases. So more number of gaseous molecules will be there when pressure increases, or the gaseous molecules will move with a higher velocity. Therefore, they will hit very frequently. As the hitting is very frequent, the distance traveled between hits will be very short. Therefore, mean free path lambda decreases with increase in pressure. And also it increases with increase in temperature, because the temperature it is directly related. So the collision can be considered in two different types. One is among the molecules. Another one is on the walls of the container. So look here, if lambda is very small, what means that before moving a small distance movement, it hits with other molecule. In such cases, the collision with the molecules is very high, then it is more than the collision with the walls of the container. This is what is experienced by the gas molecules at normal pressure. That is 1 atmospheric pressure. What will happen? The collision among the molecules will be more than the collision on the walls of the container. In such cases, the lambda is very small. Suppose if you evacuate the container and make the container a vacuum, in such conditions, the molecule, suppose only one molecule is found in the container, it will hit only on the walls of the container, because no more gaseous molecules there to hit with this one molecule. In such cases, the number of collisions on the walls will be greater than the number of collisions among the molecules. In such cases, lambda is very large. So lambda is always taken in terms of molecular diameter. How many number of diameter of the molecules the gas is freely moving without getting hit. So if a gas is a system containing the two, that is the frequency of a collision on the walls of the container greater than the collision among themselves, then that gas is called Knudsen gas. That gas is called a Knudsen gas. This is called mean free path. So with this, we come to the end of the gaseous stage.